Good evening, kiddos. So what we're going to be doing today is working on some trigonometric ratios. Now, what I want to do, this is going to focus somewhat on this current worksheet, but I want to do a little bit more than simply work through problems. I want to start briefly by talking about what it means for what sine, tangent, and cosine mean, or sine, cosine, and tangent. Here we have a right triangle, and you have to understand sine, cosine, and tangent are trigonometric ratios. Trigonometry, as far as we're going to study it, only applies to right triangles. So if you have that A there, you have the capital A as the top angle, and notice that opposite the A is Coco Shush. Opposite the A is side A. Same for B and C is the hypotenuse. Now, the hypotenuse is only going to occur in a right triangle because it is always opposite the 90-degree angle. So, the sine of A is going to be the opposite over the hypotenuse, and that is going to be A over C. Why? Because as we can see, A, opposite of A, and then the hypotenuse, C. So the sine of A, opposite over adjacent, means, and when we're talking, not opposite over adjacent, opposite over hypotenuse, when we're talking about this, we're talking about the sides. So the sine of an angle is a ratio of the sides. Okay, so now moving forward, the cosine of A. Now cosine here, we're going to talk about adjacent over hypotenuse. So if this is our angle here, adjacent means same or next to. Doesn't mean same, it means next to. So we look at we know that this is our hypotenuse, but the one next to this angle is this side right here, that little b. So the cosine of A, which is adjacent over hypotenuse, is going to be b over c. And then finally we have our tangent of A, and that equals opposite A, we already went over that, A over adjacent B. Now notice that those places of adjacent and opposite, they're going to switch when we get to, so let me put that back there, okay, when we get to B. Because now for B, the opposite side is that little b. Hypotenuse, still C. But the sine of B is not going to be the same as the sine of A. So same thing, cosine of B, we're going to look at the adjacent side to B, which is right there. So it's going to be A over hypotenuse. The hypotenuse remains the same. I think that's a Led Zeppelin song. So then we have tangent B equals B over A, because again it's opposite, that blue, over adjacent, red. So now notice something. If we look at those two, we see that the sines and cosines kind of switch for each one. And that makes sense, because if we sit there and we focus on A, right here, then opposite of A is going to be side A, and adjacent to A is going to be side B. But if we switch our focus and we're looking at this triangle from B's perspective, then opposite is now going to be B, and A is now going to be adjacent. Think about it this way. If you lived in California, the opposite coast would be the East Coast. However, if you live in New York, and I said opposite coast, then I would mean the West Coast. So whether or not a side is opposite or adjacent is directly related to which angle you were talking about it from. Okay, so that gives us SOHCAHTOA. And hold on just a second. Okay, so this is SOHCAHTOA, and I'm going to rewind a little bit and kind of review what exactly this means. So sine, as we just talked about, is the ratio of the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse. And tangent is the opposite side over the adjacent side. And when we put these together, we get SOHCAHTOA. And that's, you can chant it kind of like the fish in Nemo. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. I'll tell you what, 5 extra credit points if anyone makes that their ringtone. Okay. So, that's what we're dealing with. So, let's work some problems now. So before we get started, I want you to do something on your calculator. Now you're going to need a calculator for this assignment. If you don't have one, I suggest the Real Calc, C-A-L-C app. That's what I use on my phone. If you have an iPhone, you can do most of this with the built-in iPhone calculator. So I want you to find the sine of 62. Now sine, cosine, and tangent, each of them we abbreviate with 3 letters. So that seems silly when we're talking about sine, which is S-I-N-E, and we're abbreviating it down to 2. But it makes more sense when we have cosine and tangent, excuse me, which we are abbreviating down from 6 letters each, down to 3. So if you hit sine 62 on your graphing calculator, or 62 sine on your scientific calculator, you're going to get the answer 0.88. It's actually 0.88 something. It's an irrational number, but it rounds to the nearest hundredth as 0.88. Now what this means is as follows. The ratio of the side opposite a 62-degree angle over the hypotenuse. Now, because it's a hypotenuse, let's make sure everyone knows we're talking about a right triangle, is always 0.88. So it doesn't matter how big the triangle is or how little the triangle is. If the 3 angles inside that triangle are 62, 28, and 90, then the ratio of the side opposite the 62-degree angle over the hypotenuse will always, 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 always be 0.88. Now, instead of writing that down, though, we just write the sine of 62 equals 0.88. So now we're going to get to some worked problems. Now, for those of you who are hoping that I'm going to sit there and answer half the questions on the worksheet, you're out of luck. What I am going to do is I'm going to go back over the ones we've already done and kind of break it down as clearly as I can. If this isn't working for you, if what I'm saying isn't making sense, always feel free to say, hey, Mr. Bernard, is there another way to describe it? So right now we have our SOHCAHTOA, so we know that sine is opposite over hypotenuse. We know that cosine is the adjacent over hypotenuse. And we know that tangent is the opposite over adjacent. So if we have sine C, start off by going sine equals opposite over hypotenuse. Okay? So we're looking for the sine of C. So that's angle C right there. So we go, what leg, or what side of the triangle is opposite of C? Well, the sine of C then is going to be opposite, is going to be 28, over the hypotenuse, 35. And then that gives us, we take out a 7 from both, and we get 4 over 5. And that's it, guys. Literally, that is it. Find the value of each trigonometric function, 1 through 15. All you're going to do is set up those ratios and reduce them. So the next one, tangent of x. Well, we know that tangent equals opposite over adjacent. So now we need to find our reference angle. Remember how we talked about whether it's opposite or adjacent is depending on your point of view. Remember, if you live in Boston, you're adjacent to the east coast, opposite of the west coast. You live in San Francisco, you're adjacent to the west coast, opposite of the east coast. So the tangent of x, so let's look, what is opposite x? Well, that's going to be 15. Now adjacent, now technically we have two lines which are next to x, which create angle x. But one of those is the hypotenuse. So we're going to go with the other one. 36. 15 and 36 have a greatest common factor of 3. So we're going to factor that out. And we're going to get the tangent of x equals 5 over 12. If at any point this doesn't make sense, rewind it. Go back, watch it a couple times. Hit pause, work some problems out on your own, see if they make sense, and then move on. So, if we were to look at number 3, because I want to do a sine, a cosine, and a tangent. Number 3, cosine of z. So we know that cosine equals adjacent over hypotenuse. And so there's z. So we're going to look adjacent. Again, adjacent is next to. So you're going to go, if I live in Boston, I'm adjacent to the East Coast. Z is adjacent to 28. And then the hypotenuse is 35. The hypotenuse is always directly across from the 90-degree angle. Always, always. It is in a right triangle. It is always the longest side, and it is always directly across from the 90-degree angle. So we're going to drop our 35 in there. 28 over 35. Hey, that looks familiar. Reduced by 7. We're going to get 4 over 5. So notice how the proportions of this triangle in number 1 are exactly the same, or number 3 are exactly the same as they were in number 1. They're both 21, 28, 35 triangles. So what that means is that the cosine of z, which is opposite the 21, is going to be the same as the sine of a, which is opposite the 21. I hope that makes sense. Remember, sine and cosine switch. So here, we can see that they have kind of the same thing going on. Okay, moving on. So now I want to jump forward to 16. Now 16 through 25 are a little bit different. Because instead of being given the sides and just being told to find the ratio, you're now going to have to use your inverse sine or inverse cosine or inverse tangent and figure out what the angle is. So, hold on just a second while I'll explain this. Okay, so if you already get what it means for the inverse sine or inverse cosine, and all you're really looking for is how to work the problems, then go ahead, just fast forward because you don't need this. So here we have our kind of basic 30, 60, 90 triangle. So we know our sides are 1, square root of 3, and 2. Now as big as we make this triangle, we could triple it in size, and the same basic ratio of 1 square root of 3, 2 would exist. So if we were to go, what is the sine of 60? Well, the sine of 60 is going to be opposite, square root of 3, over the hypotenuse, 2. Simple enough. Cosine of 60, adjacent, 1, over the hypotenuse, 2. And finally, tangent of 60 is going to be the opposite, square root of 3, over the adjacent, which is 1, and that just reduces to the square root of 3. So now we're going to talk about sine to the negative 1. Now on your calculator, this would be the button or symbol directly above your sine button. So to access this, you're either going to have to hit second sine or shift sine. So if we have sine to the negative 1, we say that is inverse sine or arc sine. And what this means is instead of, if I hit sine 60, or let's say cosine 60, it would say 0.5. So if you have a calculator out, do that really quickly. Just make sure. Hit cosine 60 or 60 cosine, and it should give you 0.5. No, go ahead. I'll give you time. Don't worry about it. Okay, so now that you've done that, what that tells you is you're asking your calculator, what is the constant ratio of the adjacent side over the hypotenuse for 60? And you get 1/2. So now when we use the inverse ratio, so took a little break, killed my bird, and now I'm back. Don't worry, no actual birds were hurt during the making of this YouTube video. So instead of sitting there and saying, what is the constant ratio of the side opposite 60 over the hypotenuse, and that'd be the sine of 60, we are now going to sit there and ask our calculator, hey calculator, what angle would give me a sine of the square root of 3 over 2? And so that's what the inverse sine is. So instead of saying, what is the sine of an angle, we're giving our calculator the sine ratio, and we're saying, calculator, tell us what it is. Now look at this. If we do that on our calculator, we're going to get 60. If we say, what angle gives us a cosine of 1/2, our calculator will say, why, Mr. Renard, it is also 60. And if we say, calculator, what angle will give us a tangent of the square root of 3, the calculator will say, why, Mr. Renard, that too is 60 degrees. So notice that each angle is going to have its own unique sine, cosine, and tangent. And it is this kind of, for geometry purposes, it's this 1-to-1 ratio that only 60 will have a cosine of 1/2. Okay? Only 60 will have a sine of square root of 3 over 2. Only 60 will have a tangent of the square root of 3. And that makes it very easy for our calculator to kind of sit there and line that up. And go, if you're telling me that the angle has a cosine of 1/2, that angle must be 60. And that's what inverse or arc trigonometric ratios are. So back to the worksheet. We're going to look at number 16 here. So 16, we have this angle right here, and I'm going to erase the question mark and call it x just because I want to, frankly. And so what we need to do is we need to find x. So what do we know about x? Well, we know that its sine is going to be 72 over 90. So that's opposite over the hypotenuse, 72 over 90. And when we plug that into a calculator, 72 divided by 90, enter, we're going to get 0.8. Okay? So now we're going to ask our calculator, what angle has a sine of 0.8? Because like I just said, that's a 1-to-1 ratio. Only one angle is going to have a sine of 0.8. So we're going to hit second sine, second dash. Now on a graphing calculator, the ones we're using in class, that dash is underneath the 3. If you have a different calculator, it may be somewhere different. And when we do that, that's going to show up. So we're asking the inverse sine of our answer 0.8. And when we hit enter, it's going to give us 53.1. Now you may want to ask me, Mr. Renard, what if we didn't use sine? What if we used cosine or tangent? And I say, well, that's okay, child. They all come out to 53.1. If I use the cosine of that angle, my ratio would be 54 over 90 or 0.6. When I ask I'm up here at the top right now. When I ask my calculator, what unique angle has the unique cosine of 0.6? It's going to go, why 53.1? And finally, my tangent is 1.3 bar, or 1 1/3. So if I ask my calculator to find me the exact angle and the only angle that has a ratio of 1 1/3, that's the inverse tangent, it will say, Mr. Renard, the answer to your question, again, is 53.1. Okay, so that's how you're going to do 16 through 25. Now, in my opinion, I would pick one of the functions, sine, cosine, or tangent, and use that all the way through. Get really familiar with that one, and you may not believe it, but if you get really familiar with sine, that by eliminating what cosine and tangent are, you're actually going to get better at them too. It's called a negative example, not that you care. So, let's look at these last 6 now. 26 through 31. Actually, I think it's through 33, so there are 2 not on the page. So here, they're going to be a little bit different. We're given the angle and one side, and then we're being asked to find another side. Now, if you can remember that sine, cosine, and tangent are just regular ratios, this might make a little bit of sense. So what we're going to do is we're going to set up number 26. So we know that we have a 15-degree angle, and we are given the adjacent side and the hypotenuse. So we look over at our little SOHCAHTOA drawing from earlier in our notes, and we say, hey, sine is opposite in hypotenuse. Tangent is opposite and adjacent. But sine, or cosine rather, is adjacent and hypotenuse. So we know cosine of 15 is going to be 16 over x. So what we can then do is switch those out. If you don't understand how I just did that, multiply both sides by x and divide by the cosine of 15. So I get 16. This is how I do it on my calculator. 16 divided by the cosine of 15. Enter. That's going to give me 16.6. So now I'm looking at number 29. And I'm going to go the sine of 70, because again, if I look at what I have x over the hypotenuse. Now this time they actually gave me the hypotenuse. So watch how I do this one differently is how do I do number 26. I don't want you automatically thinking that just because we're missing a side that you can switch them around. Here, instead of taking 15 and dividing it by the sine of 70. We're going to take 15 and we're going to multiply it by the sine of 70. And because we do that, we multiply both sides by 15. The 15s on the right cancel out. So we get x equals 15 times the sine of 70. So in our calculator, we'd hit 15 sine 70, enter, and that is going to give us our x value of 14.1. Again, we set up the appropriate ratio based upon the information given to us. And using that information and that ratio, we basically set up an algebra problem, in which case the data could be accessed. Specifically here, the length of the missing one. So, you don't need to worry about any of this. And this is number 27. So you have cosine of 66. Why? Because you're given the adjacent value and the hypotenuse. So you set that up as cosine 66 equals 10 over x. You then switch the cosine 66 and the x. So you get x equals 15. Sine 70 equals x over, I don't know what just started happening. You guys can figure that out, though. I think I did this in two different, I don't know. It's going all stupid now. Okay. So here finally is 33. These are our last two. I'm not actually going to do these for you. I'm just going to help you set them up. So that's going to be the tangent of 73. Why 73? Or y tangent, because if I look there, I see that my opposite, my 73 is my opposite one. Adjacent to the 73 is my 12. I remember that my trigonometric ratio is that tangent equals opposite over adjacent. So that's what I do. I put it as opposite over adjacent. If you have any further questions on this, let me know. If you're stuck on a specific problem, either drop me an email or ask me tomorrow. Other than that, have a wonderful weekend, everybody. And I know this is a little bit long, but I truly hope that this helped you better understand sine, cosine, tangent, and their uses.